Orion is the only spacecraft capable of taking humans to lunar orbit. But in order for those humans to get to the surface, it needs to master the art of docking with multiple space systems, like orbiting space stations, human landing systems, and other vehicles. This activity, known as rendezvous, proximity operations, and docking, otherwise known as RPOD, is a critical element of Orion's mission.
Rendezvous is the process of bringing two space vehicles to the same vicinity of each other. Proximity operations is where you start moving one vehicle around the other, and then the last part of that is the docking, where the two vehicles actually come together and connect.
Lockheed Martin and NASA developed Orion's RPOD system, which uses a combination of LiDAR, cameras, and computers to guide Orion into the correct docking position.
So we have a docking camera, and that is used when we're at far range. After that, we switch over to a LiDAR system, and we actually have two LiDAR systems on Orion, then give us much more detailed information than a single camera can. So a camera allows us to pinpoint the direction to something, but once we were able to switch to the LiDAR, then we actually get really detailed information about how fast we're closing with that other vehicle and exactly where it is.
To ensure precise and accurate docking, the RPOD system is put through extensive testing at Lockheed Martin's Open Field Range near Santa Cruz, California, and its Space Operations Simulation Center, or SOSC, in Littleton, Colorado. In Santa Cruz, engineers used a custom-built drone that flew toward a LiDAR system to simulate Orion's flight path, speed, and angles during its docking approach.
We began last year at the Santa Cruz facility out in California, and at that facility we were able to test from our maximum ranges down to about 10 meters. Of course, the last 10 meters is the most important part of any docking, and so that's why we come to this facility where we can test from about 50 meters range down to 0.
At the SOSC, engineers perform the RPOD maneuver at closer distances with more precision. These simulations utilize the entire suite of LiDAR, cameras, and flight software.
In addition to the hardware, we have a big software effort behind all of these. So there's software working with the camera and the LiDARs that then takes that information, passes it to the flight control computers, and then in fact gets all the way to pushing the different thrusters on Orion to make sure we're steering and going in the right direction.
If necessary, the RPOD system also provides an option for manual crew override, ensuring a safe and reliable docking process hundreds of thousands of miles away from Earth.
So the idea of the Orion docking is that it is an automated process. That said, the astronauts are of course very interested in what's going on. This is a very dangerous operation, so they're paying very close attention to things. They can immediately disable the automatic systems and then fly using the docking camera data, and then they could actually complete the docking if they needed to.
Orion is poised to undertake an important RPOD test during the Artemis II mission, ahead of its first actual docking procedure at the Moon during Artemis III, leading to the first crewed lunar landing since the Apollo era. The ability to dock safely and precisely is crucial for the success of Orion's missions and future missions to Mars.